Good morning, class. We are looking at Chapter 7, Analytic Trigonometry. We're going to cover double angle and half angle formulas, and we're going to continue solving trigonometric equations. So the objectives are use double angle formulas to find the exact values, to establish identities, use half angle formulas to find the exact values, use double angle formulas to solve equations. Again, the fundamental identities are discussed. The fact that all of them are periodic functions. All of them are odd functions with the exception of cosine and therefore secant. Fundamental identities such as Pythagorean identities, quotient identities, and reciprocal identities. And we recall the sum and difference formulas. For example, sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. Now, here's the summary of the section, and we look at more details shortly. Double angle formulas from B4. The half angle formula, sine of alpha over 2 is plus minus the square root of 1 minus cosine alpha over 2. Cosine alpha over 2 is plus minus the square root of 1 plus cosine alpha over 2. It's the same thing with the negative changes to positive, and tangent is the ratio of sine to cosine. This is what we get. It also becomes sine of alpha over 1 plus cosine alpha, 1 minus cosine alpha over sine alpha. Sine squared is 1 minus cosine to alpha over 2. And cosine squared is 1 plus cosine to alpha over 2. Now, you can cut the alpha in half. Therefore, you cut the 2 alpha in half. You cut the alpha in half, you cut the 2 alpha in half. And tan squared of alpha is 1 minus cosine to alpha over 1 plus cosine to alpha. And for half of it, again, you cut this one in half, you cut these two in half. So that's the synopsis of that. What I want to do is to quickly go over the proof of this. Sine of 2 alpha is 2 sine alpha cosine alpha. Okay. And to prove that, we write sine of 2 alpha as sine of alpha plus alpha. And over here, we are going to use this formula. Instead of beta, we're going to use alpha. So according to that, sine of alpha plus alpha, if you replace this with alpha, sine alpha, cosine alpha, plus cosine alpha, sine alpha, and that is 2 sine alpha cosine alpha. We want to prove cosine of 2 alpha is cosine squared alpha minus sine squared alpha. So we write the same thing. Sine, we wrote it as sine of alpha plus alpha. Cosine of 2 alpha, we're going to write cosine of alpha plus alpha, and we use this formula. Cosine of alpha plus alpha. So if you change this one to alpha, you get cosine alpha, cosine beta, cosine alpha again, beta becomes alpha, minus sine alpha, sine alpha. Okay, and this is cosine squared alpha minus sine squared alpha. So I want to make sure we understand what we are doing here. So this one is used here. This one is used here. Very straightforward, everybody. Now, so that's one of them. Since Sine squared plus cosine squared, they add up to 1. Sine squared plus cosine squared, they add up to 1. We can say sine squared is 1 minus cosine squared. So if we replace this with 1 minus cosine squared, or if we replace it with cosine, the cosine squared, we replace it with 1 minus sine squared. We end up with the following. So cosine of 2 alpha has 3 possibilities. Cosine squared alpha minus sine squared alpha, we proved it here. Could be 2 cosine squared alpha minus 1, right? Because if you apply the negative, this becomes minus 1, this becomes plus, we get 2 of them. If you use this one here, replace the cosine squared with 1 minus sine squared, then we have 1 minus sine squared, we get 1 minus 2 sine squared. Those 3 are extremely important and they come very handy. But this is the one we proved with cosine of 2 alpha, and using Pythagorean identities, we can expand it. Now, if I want to solve for sine squared now, look at this formula. If I want to solve for sine squared, I'm going to take the 1 to the other side. Or better yet, let me just write it at the top of it here. So you see how that works, and then the rest of them you can figure out. So over here, I can move this and write down 2 sine squared alpha is 1 minus cosine of 2 alpha. All I have to do, divide both sides by 2. Okay. Okay. And I get this one. Sine squared is 1 minus cosine of 2 alpha over 2. Let me clean up the mess. It'll be easier to follow. We can do the same thing here. If you move the negative one to this side, and divide by 2, you get cosine squared alpha is 1 plus cosine 2 alpha divided by 2. Very straightforward, everybody. What is tangent? Sine over cosine. So what is tan squared alpha? Sine squared alpha over cosine squared alpha. Tangent is sine over cosine. Tan squared alpha is sine squared over cosine squared. And sine squared, I can use 1 minus, if you divide this one by this one, I hope you realize the denominators the same are going to be dropped. So divide this by this, you get 1 minus cosine 2 alpha over 1 plus cosine 2 alpha. Now, if I cut this in half, if cut the alpha in half, I get tan squared of alpha over 2. Then I have to cut this in half. I get alpha, I get alpha. Cut the alpha in half. Okay, becomes alpha over 2. This becomes alpha. This becomes alpha. Let's do the same thing here. If I cut this in half, I get 1 plus cosine alpha divided by 2, cosine squared of alpha over 2. Same thing here. Cut this in half, cut this in half. And believe it or not, those are the proofs. And we will continue with more.
I have a question.
Go ahead.
When we cut it in half, what happened to the 1 and 2? Why wouldn't we do anything with it?
You let alpha is a variable. let two over here. So let me use a different color so it becomes clear. Hold on. Let 2 alpha be theta, just for the sake of argument. Then alpha becomes theta over 2. Agreed?
Yes.
Okay. So if that's the case, I have to replace the alpha with theta over 2, and I'm going to replace the 2 alpha with theta. That's the same concept. Perhaps if you use a different variable, it makes it easier to follow. But it doesn't, nothing happens to the numbers. You are simply using a different variable. Okay. Let 2 alpha be x. Let 2 alpha be theta. So I'm going to replace the 2 alpha with x or theta. If I replace the 2 alpha with theta, I can't leave the alpha unchanged. Alpha becomes theta over 2. So that's the reason for it. All right. Tan of 2 alpha is 2 tan alpha over 1 minus tan squared alpha. And to prove that, we are going to use the fact that tan of alpha plus beta is tan alpha plus tan beta over 1 minus tan alpha tan beta, and replace the beta with alpha. Replace the beta with alpha, because 2 alpha means alpha plus alpha. So in this formula, wherever you see beta, change. Therefore, you have 2 tan alpha over 1 minus tan squared alpha. From the previous page, cosine squared alpha over 2 is 1 plus cosine alpha over 2. Sine squared alpha over 2 is 1 minus cosine alpha over 2. And tan squared alpha, we just showed it in the previous page, 1 minus cosine alpha over 1 plus cosine alpha. So if that is the case, what should be cosine of alpha over 2 or sine of alpha over 2 or tan of alpha over 2? The same thing under the radical with a plus minus. Same thing, plus minus the square root. Same thing, plus minus the square root, the same thing. As far as plus minus is concerned, based on the quadrant, you make a decision if it's positive or negative. Based on the quadrant, you make a decision if it's positive or negative. And therefore, it gives rise to those equations that you see. And this last one, we're going to elaborate on that in a moment. But again, more importantly, how do you figure out the plus minus? Pay attention to the quadrant. Okay, your plus or minus sign is determined by the quadrant of the angle alpha over 2. Well, tan of alpha over 2, if you look at the previous page, we had this. And we say it's also equal to 1 minus cosine alpha over sine alpha, also sine alpha over 1 plus cosine alpha. Let's quickly show that sine squared is 1 minus cosine alpha over 2. So if we multiply both sides by 2, we get rid of the fraction. So multiply this one by 2, this 2 goes away. Tan of alpha over 2 is sine over cosine of alpha over 2. If we multiply both sides, I want it to look like that. Sine of alpha over 2 also 2, the top and the bottom. Please pay attention to the fact, class, that this equals 1. So that's fine, okay? We can multiply a fraction by 1. So the top becomes 2 sine squared alpha over 2, and the bottom becomes 2 sine alpha over 2 cosine alpha over 2. As you know, this one is 1 minus cosine alpha. This one is sine of alpha. You remember sine of 2 alpha? Sine of alpha is 2 sine alpha over 2 cosine of alpha over 2. Because sine of 2 alpha is 2 sine alpha cosine alpha. And so we proved it's 1 minus cosine alpha over sine alpha. We proved that. In this case, you don't have to worry about plus minus. By the way, generally speaking, if we find the sine and cosine, we don't go with the formula. We just write tangent is sine over cosine. We take the easy way out. Now, if we multiply this, so write this, okay? If we multiply this by the conjugate of the numerator, meaning 1 plus cosine alpha, and divide by it, again, this fraction, everybody, is also equal to 1. Here's the trick we are using. And the top becomes 1 minus cosine squared. The bottom is what it is, okay? And so 1 minus cosine squared, I can replace it with sine squared alpha. These two cancel each other. The bottom goes away and the numerator changes to sine of alpha. And that's the proof of the third one. So we proved tan of alpha over 2. There are different ways to write them. For example, sine of alpha over 1 plus cosine alpha. All right. So those are the proofs. I highly recommend you go over them for a couple of times. You need to be comfortable with them, okay? If sine theta is given as 3 over 5, and theta is between these two numbers, pi over 2 and pi, these two angles, these two arcs, find the exact value for sine 2 theta, cosine 2 theta, and so forth, and we have the formulas. For example, for sine 2 theta, we need 2 sine theta, cosine theta. So we have sine theta. That means we need to find cosine theta. Now, of course, if we use Pythagorean identities, I'm going to assume we are very comfortable with that. Sine squared plus cosine squared is 1. Therefore, we know that cosine is plus minus the square root of 1 minus sine squared theta. And we replace the sine with 3 over 5. So we get 9 over 25. 1 minus 9 over 25 is 16 over 25 under the radical. So plus minus 4/5, and cosine becomes negative. We choose the negative one. Why is that? Second quadrant. Second quadrant, cosine is negative. So there are two choices. Why are we choosing negative? Quadrant 2. So plug in. Now I have everything. 2 times sine, which is given as 3/5, times cosine that we found it as negative 4/5. So that's minus, the bottom is 25, the top is 24. So negative 24 over 25. The next one is easy. It's cosine squared minus sine squared, and we have both of them. By the way, any of them you choose, you can handle it. And if for any reason we didn't have part A, everybody, and we just wanted to find this, we wouldn't have to calculate this. We could go with 1 minus 2 sine squared. I hope everybody understands. You have three choices. Again, if the question just asks for part B, part A is missing, they never asked us, then I don't even have to calculate cosine theta. I'm going to go with 1 minus 2 sine squared alpha. But over here, I'm going to go, it doesn't make any difference. Cosine squared minus sine squared. Cosine is negative 4 over 5. When you square it, becomes 16 over 25, and this becomes 9 over 25, and the difference is 7 over 25. We want to solve the equation, and we just want it from 0 to 2 pi. Anytime you have cosine and sine, okay, and you have a quadratic format, you want to change them so that both sides involve sine. Cosine 2 theta, there are three ways to write it. Cosine squared minus sine squared. Doesn't do us any good because on the right side, we have only sine squared. 2 cosine squared minus 1 doesn't do us any good. We choose the last one. Cosine of 2 alpha is 1 minus 2 sine squared alpha. So cosine of 2 theta is 1 minus 2 sine squared theta. Notice these two cancel each other because they're identical from both sides. 1 can never be equal to 2. And so we write phi, which means an empty set, which means no solutions. Let me write it out. This means no solutions. Okay. This is not 0, this is phi. An empty set notation for set theory. Sine of 2 theta plus cosine of 2 theta. There are different approaches. One easy way to take one of them to the other side. Anytime you have sine and cosine, change them to tangent. So if you divide both sides by the same thing, sine 2 theta or cosine 2 theta. If you divide by sine 2 theta, you end up with cotangent. If you divide by cosine 2 theta, you end up with tangent. Both ways work. So for example, cosine 2 theta, this gives us tan of 2 theta, and this gives us minus 1. Pay attention to the sign. Therefore, 2 theta, remember, tangent is negative in the second and fourth quadrant. So 2 theta is 3 pi over 4 plus n pi. Because the period is pi, if you wrote 3 pi over 4 plus n pi, gives you all the solutions. Even if you want to go from 0 to 2 pi, all you have to do, let n be 0. That's one solution. Let n be 1. That's the second solution in the fourth quadrant. So you're going to divide both sides by 2. You get 3 pi over 8 plus n pi over 2. And again, if we are dealing with sine and cosine, we go with 0 and 1. Because we are dealing with tangent, we can go with only one format, and we go with 0, 1, 2, 3. So if you plug in 0, you get 3 pi over 8. By the way, this is done. But if you want specifically from 0 to 2 pi here, okay, so this would be the general solution, and you're done. Specifically from 0 to 2 pi, plug in 0, 1, 2, 3. For example, if you plug in 0, this goes away, you get 3 pi over 8. If you plug in pi, if you plug in 1, you get pi over 2 plus 3 pi over 8. Pi over 2 is 4 pi over 8 plus 3 pi over 8 is 7 pi over 8. So I did the first one and the second one. Plug in 2 pi over 2, or simply pi, or 8 pi over 8. 8 and 3 is 11 pi over 8. 50 pi over 8. So you can get all of them easily. I'm assuming we are okay with that class. When we have multiple angles, we write the general solution, we solve for theta, and then we move on accordingly. Again, if it were sine or cosine, we would have to have both of them and then divide by 2 and then just 0. And write cosine to the power of 4 theta in a format that does not involve powers of sine or cosine. Here's the process. Cosine to the power of 4 is cosine squared squared. And we want to go with cosine. So cosine squared is 1. Cosine squared of alpha is 1 plus cosine 2 alpha divided by 2. So we're going to replace this with 1 plus cosine 2 theta. Okay, just theta or alpha or beta or x makes no difference. Okay, it's just a variable, dummy variable. Let's raise this to the power of 2. To do that, the denominator is 4, everybody. So we're going to say 1/4. We raise this to the power, we get 1. And then 2 times the first times the second is 2 cosine 2 theta. And then you raise this to the power of 2 plus cosine squared 2 theta. And remember, I put the 1/4 in front to take care of the whole thing. So it says doesn't involve powers of sine or cosine. So 1/4 times 1 times this one becomes 1/2 cosine 2 theta. So far, so good. But this one is powers, and this is the 1/4 of cosine squared. We are going to change that. So the first one is a number. The second one doesn't involve power. The third one, this has to be changed according to the question. So we keep this, we keep this. And what about this one? Cosine squared 2 theta, we're going to follow that. Again, look at this 2 theta, everybody. If you let alpha be 2 theta, then 2 alpha becomes 4 theta. That's actually the question that came up. So you keep the 1/4, you go with this one and you put 1 plus cosine of 2 times 2 theta divided by 2. So this is 1/4. This is half of cosine 2 theta. This is 1/4 times 1/2. By the way, just right away, just make this 1/8. So 1/8, 1 plus cosine of 4 theta. And distribute the 1/8. This gives us 1/8, and this gives us 1/8 cosine of 4 theta. 1/4 and 1/8. 1/4 is 2/8, and 1/8 is 3/8. The rest remain unchanged. The rest remain unchanged.
Wait, I have a question.
Go ahead.
How do we get the 3 again?
This one you mean?
Yes.
1/4 equals 2/8. 2/8 plus 1/8 is 3/8. You okay with that?
Okay, that makes sense. Thank you.
Sure. All right, we want to solve this equation. Cosine of 2 theta minus sine 2 theta sine theta equals 1/2. This is like cosine of alpha, cosine of beta minus sine of alpha, sine beta, where alpha is 2 theta, everybody. Think about this. Think of this as alpha, think of this as beta, and reminding you of the formulas here. So what we are looking at is this one, everybody. Cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. This is the formula we're going to use. Therefore, the left side is cosine of alpha plus beta. Cosine of alpha 2 theta. Cosine of beta, the beta is theta. So cosine of 2 theta plus theta. So the left side is cosine of 3 theta, and that's 1/2. And 1/2 is a common arc. You know, cosine is equal to 1/2 when it's pi over 3 in the first quadrant, or 5 pi over 3 in the fourth quadrant. Cosine is positive in those quadrants. Therefore, either pi over 3 plus 2k pi, or 5 pi over 3 plus 2k pi. Again, we've discussed the reference arc is pi over 3, and this one is pi. 2 pi minus pi over 3, which makes it 5 pi over 3. In general, we make it 2k pi. Divide both sides by 3. This becomes pi over 9. This becomes 2k pi over 3. This one becomes theta. This becomes 5 pi over 9 plus 2k pi over 9. That would be the general solution. If we were interested in finding the solution from 0 to 2 pi, then you let k be 0, 1, 2. Okay, class? This is 3, right? You go from 0, 1, 2. Unlike tangent and cotangent, that we could go further because we could show it with 1, that in the case of a tangent and cotangent, 1 represents both of them. Okay, but that's not the case here. So you would choose theta equals 0, 1, 2. An object is propelled upward at an angle of theta, where theta is between 45 and 90 degrees. To the horizontal with an initial velocity of v sub 0 feet per second. If air resistance is ignored, the horizontal distance r that it travels is given by 1/16 v0 squared sine theta cosine theta. Show r is 1/32 v0 squared sine 2 theta. Okay. It's a very straightforward process. This is given. As you know, sine 2 theta is 2 sine theta cosine theta. Therefore, this is half of sine 2 theta. According to this part is half of it, multiplied by 1/16, and believe it or not, that's the proof. Find theta to maximize r. Well, here's r. What could maximize this? Sine 2 theta has a maximum value of 1, and it can't be larger than that. So when would that be? 2 theta equals pi over 2 results in sine 2 theta be 1. This is the maximum value because sine is between -1 and 1. We have no choice. Therefore, theta can only be half of pi over 2 or pi over 4. So again, I want to make sure we understand that. The maximum for this happens when this is max. You can't change anything else, class. This is the only one we are hoping to maximize, and we can maximize it by getting 1 out of it. To get 1 out of it, theta must be pi over 4. Use a half-angle formula to find the exact value of sine of 22.5 degrees. That means you want to use common arcs that you are familiar with, everybody. And in this case, we are clearly using what? 45 degrees. So sine of 45 over 2, which is using this formula plus minus the square root of 1 minus cosine alpha over 2. However, 22.5 degrees class, we all know it's in quadrant 1 and it's positive, right? So we just take the positive one. And cosine of 45, everybody knows it to be square root of 2 over 2. It's a common arc. If I look at this fraction inside the radical, it's a complex fraction. So if I multiply 2 over 2, what happens, the product of these two is 4 and it comes out as 2. And this one is 2 and this one is minus square root of 2 and that remains. So please understand, this gets multiplied by these two and remains. This gets multiplied by this, becomes 4, comes out as 2. Okay. How about cosine of 5 pi over 12? Well, 5 pi over 12 is not a common arc, but 5 pi over 6, if you divide this one by 2, if you divide the denominator by 2, the fraction gets larger by a factor of 2. 5 pi over 6 is a common arc, and 5 pi over 6 divided by 2. Again, please notice this is in quadrant 1 because 6 pi over 2, 12 is pi over 2, so this is less than pi over 2, and this means also quadrant 1. And so if we are using this plus minus, we use the plus, quadrant 1. Now, cosine of 5 pi over 6 is the same as cosine of pi over 6 as far as the reference arc. I want to make sure we understand how we arrive at the answer. So for this, the reference arc is pi over 6. So 5 pi over 6 puts us in the second quadrant. In the second, cosine of pi over 6 is square root of 3 over 2. In the second quadrant, cosine is negative, minus square root of 3 over 2, okay? Again, reminding you of things that we've done. Again, we're going to multiply by 2 over 2, and the same thing happens as this one. The top 2 times that remains inside, the bottom is 4, comes out as 2, and that's the exact answer. Again, exact answer, and that's really the key, everybody. All right, we are going to move on. Cosine is given as negative 1 over 5. And alpha is between pi over 2 and pi. And we want to get the sine, cosine, and tan, all of them alpha over 2. So we just use the formula for sine. We write plus minus square root of 1 minus cosine alpha over 2. So we can use that. But is it plus or minus? Since we want to go with alpha over 2, half of this, okay, is pi over 4. Half of this is pi over 2, and it puts it in the first quadrant. So half of pi over 2 is pi over 4, half of pi is pi over 2. And so alpha over 2 is in the first quadrant. Makes it positive, so plus minus, we just use the plus. This formula. And replace the cosine of alpha with negative 1/5. They add up to 6 over 5. Right? 1 minus 1/5 becomes 6 over 5. Uh, 6 over 5 divided by 2 is 3 over 5, again, under the radical. If you rationalize it by multiplying the top and the bottom by 5 inside the radical, the bottom 5 comes out as 5, and the top square root of 15 remains. This is rationalization. Again, in case you don't have to do that, it depends how they want it. Rationalization is really a good idea, but in any event. Cosine, again, we're going to use the plus sign, and practically will be the same thing here, but with the plus sign here. So plus minus 1 over 5, and therefore 6 over 5 now changes to 4 over 5, 4 over 5. 4 over 5 divided by 2 means 2 over 5. I'm assuming nobody has any problem with, fractions. Again, if I multiply this by 5 over 5 inside the radical, I want to make sure we understand. So we are, in essence, continuing. This one is in. Okay. And we do the same thing inside. Okay. Now the bottom comes out as 5, and the top remains as 10 inside, square root of 10 over 5. Now, in order to get to the tangent class, I'm not going to go with that formula. I'm going to go with sine over cosine. That's the fastest way. Since I have the sine of alpha over 2 and cosine of alpha over 2, the fastest way, just divide this one by this one. The bottom is 5. You drop it. It's a complex fraction. Square root of 15 over square root of 10, or square root of 3 over 2. Now, if I multiply this by square root of 2 over square root of 2, it gets rationalized. The top becomes square root of 6, and the bottom comes out as 2, and we are done. Cosine of alpha is given, and alpha is between pi and 3 pi over 2. We want to find the exact value for sine of alpha over 2. We have the formulas, and we know that alpha is between these two numbers, right? Pi and 3 pi over 2. So alpha over 2, cut everything in half. It's in pi. This is pi over 2. This is 3 pi over 4, and it puts us in the second quadrant. And in the second quadrant, sine is positive, so plus minus, we choose the plus. Okay. Square root of 1 minus cosine alpha, 1 minus negative 3 over 5. So this makes it plus, and it makes this the numerator. I hope everybody's okay. That 1 plus 3 over 5, the numerator is 8 over 5 divided by 2 is 4 over 5 under the radical. There are different ways of approaching it. You can take the 4 out, and I hope you see that if I multiply this one by square root of 5 over square root of 5, I get 2 square root of 5 over 5. The bottom line is, the rest is elementary algebra, and I hope everybody's okay with that. Okay. What about cosine? We are going to use plus or minus. In the second quadrant, you said the second quadrant, we know cosine is negative. So we use the same formula here, but with a negative sign. So minus the square root of 1 plus cosine alpha. And I put it in red so everybody can see why we are using it, okay? Now, obviously, this is 2 over 5. 2 over 5 clearly divided by 2 is 1 over 5. So minus the square root of 1 over 5 is minus 1 over the square root of 5. Again, we do the same thing. If you put square root of 5 here, square root of 5 here, it becomes negative square root of 5 over 5. And again, for tangent class, I'm going to use sine over cosine. That's the fastest and easiest way. And so 2 square root of 5 over 5 over negative square root of 5 over 5. This is the main fraction bar. And as you can see, both denominators can be dropped. So we have a 2 square root of 5 over minus square root of 5. The answer is negative 2. Establish identity that sine 4 theta is cosine of theta times 4 sine theta minus 8 sine cube theta. If you want to establish identity, you really can start from any side you want, the right side, the left side, normally the more complicated side, but many times, and we can discuss that, we've seen this, they may say, okay, go from here to here and proceed in that methodology because it's sine of 4 theta. But anyways, obviously right-hand side is easier. So if we start with the right-hand side and we distribute, we get cosine. We don't even have to distribute. We notice that this one has a 4 sine theta in common. So if from the bracket, from the parentheses, we take the 4 sine theta out, we get 1 minus 2 sine squared. So over here, take the common factor of 4 sine theta out. And notice this part is 4 sine theta cosine theta. Therefore, it makes it 2 sine of 2 theta. And this one, 1 minus 2 sine squared theta, is cosine of 2 theta. So this is this one. This is this one, which makes it 2 sine 2 theta cosine 2 theta, which is sine of 4 theta. And that's the left-hand side. Again, one way to look at it, you can let 2 theta be alpha. If you let 2 theta be alpha, this is sine of 2 alpha. Okay, if it makes it easier to understand, class. Let 2 theta be alpha. So you have 2 sine alpha cosine alpha equals sine 2 alpha. And now replace the alpha with 2 theta, and that's the proof. However you want to look at that. We want to prove that ln of absolute value of cosine theta is half of ln of 1 plus cosine 2 theta minus ln of 2. And the right-hand side is a more complicated side we're going to start. Now, the right-hand side, class, I hope you remember the natural log, in general, the logarithmic property. So I'm going to write this. You recall log of x over y is log x minus log. Let me just put it somewhere else that it's easier to see. Put it next to it actually and with a different color. So log of x over y is log x minus log y. Therefore, this part inside is ln of 1 plus cosine 2 theta over 2. In other words, we go from this side to the other side. This, I put it in general. And by the way, this is log with any base. Let me just put base a in general. And now, this 1/2 can become the exponent. The power rule for logs. The power rule for logs. Okay, everybody, the power rule for logs. Let me just write that rule also. Log base a of x to the power of n is log n log x base a. You can use that formula, the reverse process. Okay. As you know, 1 plus cosine 2 alpha over 2 is cosine squared. So this part is cosine squared of theta. Cosine squared to the power of 1/2, they cancel each other. It's just a cosine. So believe it or not, that is the proof, and that is the left-hand side. Now, this question is an interesting question because it involves a lot of trigonometric identities as well as logarithmic properties. So you want to make sure you remember all the logarithmic properties. It makes it nice and easy. Cosine 2 theta plus 5 cosine theta plus 3 equal to 0. We want to solve that. Remember, cosine 2 alpha, there are 3 ways. I can't use that because I have 5 cosine theta plus 3. I'm concerned with this one. And I can't use this one either. I want to use the one in the middle because cosine of 2 alpha involves cosine only. So 2 cosine squared alpha minus 1. I'm going to replace this with 2 cosine squared theta minus 1. Again, 3 different identities. Use the one that works easily. And now that you have that, you put them in descending order. 2 cosine squared plus 5 cosine theta. These two numbers, they add up to positive 2. And simply put, you factor them. I hope you're okay with the factoring. And I'm going to remind you again, if you want to factor this, the methodology is very simple. You say, okay, this is 2. So you put 2 cosine theta and 1 cosine theta. And then all you have to do, look at this, is 2. So you have to put 1 and 2 somewhere. And since this is positive 5, both of them are positive, but you have to work it out such that the middle term works. Take a look. This gives you cosine theta. This gives you 4 cosine theta. Do they add up to 5 cosine theta? That's the question. That's what you should ask yourself, okay? And that is extremely important to work. And it does. So therefore, cosine theta is negative 1/2. Cosine theta is negative 2. As you know, this one doesn't give you any solutions, right? This doesn't give you any solution because cosine is between negative 1 and 1. So that's out. As far as negative 1/2 is concerned, I want to go over 1/2 and refresh your memory again about the reference arc. If you take cosine theta to be 1/2, then the reference arc becomes pi over 3. So remember that. This is the reference arc. We want it to be negative. So in the second quadrant, it's pi minus pi over 3. In the third quadrant, it's pi plus pi over 3. So this would be pi minus pi over 3. This would be pi plus pi over 3. So of course, you have to do this pretty fast, but I'm still reminding you of what we have done long ago. We want to establish identity that 4 sine u cosine u times 1 minus sine squared is sine of 4u. Obviously, we start with the left-hand side. Sine u, cosine u, there are 4 of them. If there were 2 of them, would be sine of 2u. Since there are 4 of them, then it's 2 of them. 2 sine of 2u. And 1 minus sine squared is cosine. This is true, everybody. And now it's sine of 4u. Again, if you want, you can let, if for any reason you have a difficulty seeing that, you can let 2u be alpha. So what you're dealing is 2 sine alpha cosine alpha, which becomes sine of 2 alpha. And now you replace the alpha with 2u, you get sine of 4u. So that's another way of writing that, everybody. We want to say cotangent theta, theta minus tan theta over cotangent theta plus tan theta equals cosine 2 theta. And we are going to start with the left-hand side. Cotangent is cosine over sine, and tangent is sine over sine, sine over cosine. You can multiply the top and the bottom by sine theta cosine theta, or you can take a common denominator. However you look at it, if you take a common denominator of sine theta cosine theta, this becomes cosine squared minus sine squared, and this becomes cosine squared plus sine squared. I hope everybody is okay with basic fractions or complex fractions. So again, if you take a common denominator, cosine squared minus sine squared here. So now these two cancel each other because the denominators are identical. Now the top is cosine squared minus sine squared, and the bottom is 1. Cosine squared minus sine squared is cosine of 2 alpha, in this case cosine of 2 theta, and that's the proof, everybody. Show that the area of an isosceles triangle is A equals 1/2 s squared sine theta, where s is the length of one of the two equal sides, and theta is the measure of angle between them. So this is s, this is s, this is h, this is the total angle theta in between. So we start with the area equals half of base times the height. All we have to do, calculate the base, calculate the height, and put it here. So if this whole thing is theta, and this whole thing is, this is the base, by the way. This is b over 2, okay? This is theta over 2. I want to make sure we understand what's going on here. So this is b over 2, okay? And this angle is theta over 2. So all we have to do, calculate the 2, and to do that, sine of this angle is the opposite over the hypotenuse. So sine of theta over 2 is b over 2 over s. Therefore, B over 2 is S times sine theta over 2, or B is 2 times that. I'm assuming everybody can see that this times that is B over 2, so B is 2 times that. Let's find cosine of this angle. Is the adjacent H over S. Therefore, H is the product of these two. Let's plug in, replace the B, replace the H into this formula. So we have 1/2, we have S squared, and then we have 2. So S and S is S squared. That's the only thing that we keep outside. We keep these two inside with sine theta over 2 and cosine theta over 2, because this now is sine of theta. Okay, according to this formula. A rectangle is inscribed in a semicircle radius with a radius of 1, with one of its sides on the diameter of the semicircle. Express the area as a function of theta. So class, the area of any rectangle is the length times the width. Now, what is the length? This is x times x plus x, that means 2x. This is the width, so 2xy. On the other hand, if you look at this, okay, this side is 1, and sine of theta is y over 1, cosine of theta is x over 1. Okay, we are looking at this triangle. Okay, everybody. So it's 2 cosine theta sine theta. Show that it's sine of 2 theta. It is. I mean, there's really not much to do. So A of theta, we showed it's equal to 2 cosine theta sine theta. And according to the formula, it's the same as sine 2 theta. Find the dimensions of the rectangle to get maximum area. Also find the maximum area. Well, the maximum happens when sine is maximum, and the sine is maximum equal to 1, right? The maximum value for sine is 1, everybody. When would that happen? When the angle is pi over 2. So 2 theta equals pi over 2. Theta is pi over 4 or 45 degrees. So the maximum occurs when we choose 45 degrees. Now, what is the area? The area is this, 2 times cosine theta sine theta. So cosine of pi over 4 as well as sine of pi over 4 are both square root of 2 over 2. They are identical, you know that. So 2xy, or 2 cosine theta sine theta, 2 times this again. And as you know, this is 2, 2 times 2, 4, divided by 4 is 1. I'm assuming everybody can see that. We want to develop a formula for sine of 3 theta, and we use the sine of alpha plus beta, which is sine alpha cosine beta plus cosine alpha sine beta. This is the technique, and we use one of them as theta, one of them as 2 theta. Okay, so sine of 3 theta is sine of 2 theta plus theta. According to this, then we have sine of 2 theta, cosine of theta, plus cosine of 2 theta, sine of theta. So it doesn't matter which one you put, but 2 theta plus theta, theta plus 2 theta, and you develop that. Now, Sine of 2 theta, we know it to be 2 sine theta cosine theta. Cosine of 2 theta, there are different ways of writing it. For example, cosine squared minus sine squared. So we keep this one, we keep this one, we change the sine to theta, okay? Okay. So this is 2 sine theta cosine squared theta. This is plus sine theta cosine squared theta minus sine cubed theta is to add up to 3 sine theta cosine squared theta minus sine cubed theta. Sine theta is given as 1/6 and it's between 0 and power 2, which puts it in the first quadrant, and we want to find the rest of it. So if I want sine of 2 theta, it's 2 sine theta cosine theta, for example. So let's develop cosine theta and so forth. Okay, so 2 sine theta cosine theta, we're going to need to find cosine theta as it appears. So cosine theta is plus minus the square root of 1 minus sine squared. That means plus minus the square root of 1 minus 1/6 quantity squared. This is 1/36, everybody. 1 minus that is 35/36. And 35 remains, and 36 comes out as 6. Again, I can write this if you want as inside the radical as 35/36. So we take the 36 out, we make it 6. Now, is it positive or is it negative? We choose the positive because theta is in the first quadrant. Now we can plug in 2 sine theta cosine theta. The denominator is 18, the numerator is square root of 35, and we are done. Cosine 2 theta, one of the formulas is cosine squared minus sine squared. So 35/36 minus 1/36, which makes it 34/36. And of course, any fraction, put it in its lowest term, the common factor of 2 from the top and the bottom is dropped. Sine of theta over 2. So we're going to use this plus minus. We're going to use plus because this is in the first quadrant. Half of it is also in the first quadrant class. It's between 0 and power 45 degrees. So we use the plus sign. Okay. 1 minus cosine theta over 2. Okay. If you take a common denominator, or if you multiply it by 6 in essence, this is what you get. Now, I'm going to leave this for you to show. This is elementary algebra class. I'm going to leave that for you to show. This is identical to this, okay? elementary algebra, you're more than welcome to ask me if you have a question. But all it is, just okay, you just multiply by 6/6. The bottom becomes 12. 12 is 4 times 3. 4 comes out as 2. 3 remains inside. Okay. Now, for the next one, cosine of theta over 2, class. Cosine of theta over 2. When you look at, so that was the sign. When you look at this formula, this is identical to that, except the plus, the minus becomes plus. So you can see it's the same answer with the plus sign. You don't even have to work this out. Write the same thing with the plus sign. Class, please understand why I'm doing this. So we did the sign, 1 minus cosine alpha over 2. We finished it. If this is correct, then all you have to do change this to a plus sign. That's the fastest way to come up with the answer. We'll look at the last question. We want to establish this identity that's cosine of alpha plus sine alpha over cosine alpha minus sine alpha. Minus cosine alpha minus sine alpha over cosine alpha plus sine alpha is 2 tan of 2 alpha. So obviously the left-hand side is the more complicated side. The common denominator is the product of these two. And then when we take a common denominator, this times this minus this times this. Okay, so cosine alpha plus sine alpha times this one becomes squared, minus cosine alpha minus sine alpha times this one becomes squared, and you write the denominator. First of all, the denominator, this is plus, by the way. I think I thought I wrote it as a plus. Okay. And so the denominator is cosine squared minus sine squared. Cosine squared. Cosine squared minus. What about this one? Cosine squared plus 2 cosine alpha sine alpha plus sine squared minus cosine squared minus cosine squared in brackets. Let me write that because I want to apply the negative. This is cosine squared. Okay, minus 2 cosine alpha sine alpha plus sine squared. And when you apply these, negative sign changes everything. Okay, when it changes everything, this becomes negative, this becomes positive, this becomes negative. Notice cosine squared with negative cosine squared go away. Sine squared and negative sine squared go away. And these two add up to 4 cosine alpha sine alpha. What about cosine squared minus sine squared? You should know that it's cosine of 2 alpha. Now, 2 cosine alpha sine alpha is sine 2 alpha because we have 4 of them. It's 2 of those. Is 2 of those. This is 2 sine 2 alpha. 2 sine 2 alpha. The numerator, because sine of 2 alpha is 2 sine alpha cosine alpha. This is 2 sine 2 alpha. And as you can see, this is tangent. So 2 tan of 2 alpha is the final answer.